Hi everyone, welcome to Your Techie Buddy. So this is a continuation of our Java 8 interview series which is on Stream API. This is the last video, and to understand Stream clearly you should have a clear understanding of Lambda expression, on which I've already created the video. Please do watch those videos first to be able to efficiently use the Stream API in Java. So now let's get started. So the very first thing which an interviewer may ask you if you're going to attend a Java interview is what is Stream in Java 8? So we know that Stream API was introduced in Java 1.8 version, and it is used to process the collection of objects. Okay, before going to the theory, let me just give a practical example to you. Now let's understand why Stream was actually introduced in Java, right? So as you know that collections are a very integral part of the Java framework. So here I have taken a collection of integer. That means a list of integer. A collection can be a list, set, anything, right? So I've taken a collection of integer here, which is a list, right? So suppose there is a condition, get all the even numbers in the list. Okay, get all the even numbers in the list. Before the streams were introduced, how we would figure out the even numbers in this list is, or how we would process something on this list is by opening a for loop. So for each of the integer in the given list, right? If the given integer percentile 2 is equal to 0, that means it's a even number, right? So now let's print that I for all the integer I in the list. So if you see, if I run this, I've opened a for each loop on the given collection, and I'm printing the even numbers by the if condition. So if you see, there are two even numbers in the given list, 52 and 90, right? So this is how you would operate over a collection, or you would iterate over a collection before the streams. So streams, after the introduction of streams, what you can do is all these lines of code, or all, if any other operations also, if not this, any other operation you want to do on the further sorting list, you can do that with a single line. And how can we do it? We'll take the collection. Remember, the stream can be opened on a collection. We'll take the collection here, which is the list of integer. Dot, you have to open a stream. This is the syntax for that. And dot, what we'll do is, in this case, we will filter. Why? Because it is a condition. Based on this condition, the list is getting sorted, right? Whenever there is a condition which you want to check on the list or the collection, you'll use the filter. And here, for each of the n in the list, right? So AL has all these five values. For each of those n, this can be anything, n, x, whatever, right? For each of the n, if x percentile 2, same condition, is 0, what we'll do is, for each of it, this part is filtering the list. We have this list. This is filtering the list. For each of it, what we'll do, we will print it. That's it. If you see, I've converted this four lines of code into one single line. Now I'll save, I'll run this. The output would be same, 52 and 90. 52 and 90. So this is the very basic things for which the stream when introduced, when an interviewer asks you what is stream API in Java 8, or what is the significance of it. So stream was introduced in Java 8 in order to operate over the collections, in order to iterate over the collection, in order to perform certain operations over the collection. And the importance is also like the LOC is reduced, the lines of code has reduced, the code has become more readable, and we can perform multiple operations in a single line of code. So now if I explain the theory, it will be more clear. The Stream API was introduced in Java 1.8 version, and it is used to process the collection of objects, right? It accepts the functional interface so that lambdas can be passed. So if you see, this is the filter which I used here, right? The method. This filter method takes nothing but a predicate, and predicate we know is a functional interface. And how do we use functional interface? By passing lambda expressions. That's why I asked you that you should be very clear about using lambda expression. So as we know, predicate is a functional interface which takes one input and returns a boolean value. That's the reason filter is taking this predicate. It is taking one input, like each input from this. First time it will take 87 and 52, 73. So each input from this list will be checked upon with this condition, and this will return us true or false. So that's why this filter accepts a predicate. And for each of those filtered value, what we are doing a print of each. This is method reference. I've already explained in my previous videos. So this is how you use streams. So a sequence of operations are pipelined in a stream and get the desired results. Suppose here I have used a filter, right? If there are certain more operations if you want to do, so there can be sequence of operation here in the streams, right? A stream is not a data structure. Instead, it takes the input from the collection arrays or IO channels, right? Stream here itself, it is not a data structure. It acts upon something. You open a stream on something, right? Streams don't change the source, they only provide the result as per the pipe. That is very true. Here, this is what AL is, right? Our source. Our source has five integers. When we open a stream and we filtered, we perform this operation and we printed it, right? If I go ahead and print AL, which is our source, it will remain unaltered. So this is an important interview question or a concept they ask you, that if we perform this, what will be the AL finally? So AL finally will still remain the source. The source remains unaltered. So now what if you want to do something, or you want to collect this result? What you will do is, there is another terminal operation called collect, and you can collect that to another list, right? So that I'll further explain. Now stream don't change the source. Very important point. They only provide the result as per the pipeline methods, right? For example, filter a list of integer and fetch. So if asked for an example, you can give the same example to the interviewer. Okay, the very next important question is, explain what are the different parts of a stream, right? Just now I showed you how to open a stream, what is a stream and all that. So you know, by now you know, right? There should be a source, there should be a collection or something on which the stream needs to be open. So now when you do source dot stream, this is the source. So in this case, AL is the source. So AL dot stream, when we do this, is these are the intermediate operations: filter, sort, map, and n number of intermediate operations. You can have 0 to n number. It is not mandatory to have an intermediate operation. So this is also an important interview concept, right? There can be you can filter, you can sort, you can map the do mapping of the source, or directly you can use a terminal operation, right? So in this case, I have used filter. You can further sort it and you can further map it, whatever you can do. You can perform on the list. So, but the sequence matter here. If you have a source, you want to filter it, you want to shorten the data, first do that and then do the sorting or any other operation, right? That will reduce the overhead of it, right? And after all these intermediate operations are done, so this is still a stream. This is not, we are not physically collecting it. It is still a stream which is open on the source. So finally, to end the stream or to collect the end result, we need to use a terminal operation. So for example, collect. In this case, we have what is the terminal operation? If you see, I have filtered, I have used stream, I have filtered the stream. Till now, till here I have the stream. So what is the terminal operation here? For each, because it is stopping the stream. Anything which stops the stream is a terminal operation. So intermediate operation returns a stream. Remember this. Very important concept. Like whenever you have a stream open and you perform certain intermediate operation, at this point, after performing all the intermediate operation, it is still a stream. Terminal operation returns a non-stream result. How do you collect a non-stream result, or how do you print a non-stream? By using a terminal operation. The result, such as a list of it can be a list or it can be a single value, and it ends the stream. I'll give further example of terminal operations in the further slides. Okay, so now what are the intermediate operations? Zero or more intermediate operations can be done. So here, if you see, I've given the example of three intermediate operations. So you can have zero operations or you can have multiple intermediate operations. Okay, order matters. This is very important. First, filter the list, sort the list, whatever you want to do. For whichever is shortening the data, it is better, right? So you filter the list first, you sort it, and then you map it. So the order matters in intermediate operations. And for very large data set, we can use parallel streams. It enables multiple threads. Okay, when we do something called dot stream, right? It is not multi-threaded, it is a single thread. But when you do parallel stream, right, it will, this parallel stream, I'm not going into details, but at least I'll give you the highlight. So what it is, if you have multi-core system, it will use the different cores and it will act as a multi-threaded one, right? So it will open parallel sources, parallel streams on the sources, so that the execution is faster. So whenever you have a large data set, whenever the order or the sequence of operating on that data set doesn't matter to you, you can go ahead and use the parallel stream. Now some example of intermediate operations are filter, distinct, map, skip, sorted. So filter, I have already given you one example. Okay, now let me just give an example of suppose sort. So take the collection dot, you open the stream dot, there is already something called sorted. Sorted will sort the list, okay? By default, it is ascending order. So I've given many example of sorted in my previous videos or my coding videos. You can go and check that. For here, for the understanding purpose for the stream, I'm just taking whatever the default sorted thing is. You can pass a comparator and all that thing you can do here, right? Then what we'll do is we'll uh, let me collect it to, okay, I'll give the example of collect also. So take a list of integer, this I'll name it as sorted list, right? So what I'll do is I've taken the collection, I've opened the stream, we have called sorted on that so that this will get sorted in the default ascending order, and then we'll do collect. Collect is the terminal operator, and what we should we it has different methods, collectors dot toList, collector dot toSet. So if you do collectors dot toList, in this case if you see, I you have to give the list name where you want to store it. That's it. If I do s out of this list, sorted list, it should have sorted my list, so 11 should have come first, right? So this is the sorted list which got printed. Similarly, suppose I have this same value, repeated value. Okay, one more example I'm giving for collection. So what you can do is, instead of this, we'll give it as set. Okay, new has set. I'm giving an example of how to use this collectors or toList is there, right? If suppose an interviewer asks you a question, given a list of integer, give me all the unique integers in that. So simply you should open the stream. You should call the you should instead of in this case we don't need the sorted also. So this is an example, okay, where you can just use the terminal operation. You need not have to do the intermediate operations. So just for the clears thing, okay, so al dot stream will open what is the problem statement, collect all the unique integers in the given list. Okay, so in this case what we'll do is, we know set stores unique values, right? So what we'll do is we'll take the list of integer, we'll open the stream, we'll directly call the terminal method which is called collect, and instead of collect to list, what we'll do, there's something called collect to set. That's it. Now when you print this, it will give you only the unique elements in that list, which is 11 and 52 will come once, if you see, right? So this is an example where you need not have to use any intermediate operation, because your whole agenda is to get unique numbers from the given list. So you directly use the terminal operator called collect, operation called collect, where you are collecting it to a set, because we know set store only unique values, and this is how you do it. So filter is done, sorted is done. Okay, map is also very important. I'll give you an example of map also. What is map? So filter, you know, you got it right. When there are five, see, there are six elements in this list. Whenever we want to perform or we want to filter the given list or collection, we want to sorten the data based on some criteria, you want to filter the list, right? Like the even numbers, right? In that case you will go for a filter. Now what is map? What if you want to do certain things on this each element of the list? Suppose I want to increase the value of each element in the list by 1. So what I'll do is I'll take al dot, I'll open a stream. Instead of filter, I'm using a map. Now map acts on each of the element in the list, and map take the functional interface which is function. We know function takes one input, right, and returns us one output. So in this case, suppose for each of the n in the given list, what I want to do is n plus 1. Increase each of the element in the list with plus 1 value. That's it. I'll use for demonstration purpose, I'll just use for each here to print it. Now if I run this, you can see all the values in the list is increased by 1. So whenever you want to perform something on each of the element of the given list or collection, you should go for map. Map takes this and maps it to something based on whatever you have given, right? So this is all about the intermediate operations. Now let's move to what are terminal operations. So unlike intermediate operations, there can only be one terminal operation. You can have 0 to n number of intermediate operation, but you can terminate, because terminal operations are used to terminate a stream. So how many times can you terminate a stream? Only once, right? If you have opened a stream once, you can terminate it only once, right? So that's why you remember this, you can have only one terminal operation. So for each applies the same function to each element. Collect is a terminal operation. I gave you an example of for each. Before this I gave you an example of collect, right? So these are two terminal operations. What are these doing? Like for each, if you see, whatever map gave or whatever the intermediate operation returned as the size, it is a size of 6, right? So the for each also gave us the same size. Collect also same thing, it will collect on the size, but there are certain terminal operations which only give one value. So there are other kind of terminal operation which reduce the stream to a single summary element. For example, count, for example, summary statistics, for example, reduce, right? So now let me give you an example of, suppose okay, for single output, right? Suppose given this list of integers, what I'll do is, uh, let me just ask you, give return me the max value given. Suppose the interval has return me the max value from the given list of integer. Now let me take a int max. Okay, I have taken a variable called max which stores integer. Now I have to get the maximum value. So what, when we do al.stream, we open the stream. Now to get the max value of integer type, we have to map each of this element as integer, right? So what we'll do is primitive integer, right? So what we'll do is map to int. So this will open an int stream. So in this, what each of the x we will map to x. Value will be same. It's just that it will be an integer. Then what we'll do it, we will use there something called summary statistics. This is a terminal operator. This mapped everything, all these two integers, still we have the size 6. This summary statistics is a terminal operation on which we can call, there is, you can see get max, get mean, get average, get count, whatever. If you see, all these will return as a single value. So my demonstration purpose, I'll take get max. So this will return as the max value from the stream. So if you do sout.max, 111 should be written, right? 111. So for each and collect will can give you multiple results. So summary statistics or any other whatever example I gave, if you want a stream to return a single value, these are the things which you can use, right? Now ending this video with very important stream interview question. Just to sum up, I've explained everything already. Just to sum up with the questions which can be asked or how it can be asked is, what is a stream and how to create a stream? What is a stream? I've explained you. Stream is the stream API was introduced in Java 8, and the main purpose of having stream is to operate over a collection, and we operate over a collection and perform different operations on that. And the advantage is that the lines of code have reduced, code readability has increased. And what are the different parts of stream, as I explained you in this diagram, right? If you explain the interviewer this way, you are going to impress them a lot. And then what is the difference between map and filter? I told you when to go for filter, when you want to shorten the list or filter it based on certain criteria, then you can go for filter. What is map? When you want to do something on each of this, I increase the value with one, then you'll go for map. When to go for map and when to go for filter, I told you, right? And what is a terminal operation in stream with example? Explained you for each, collect, reduce, and what are summary statistics. So these are the terminal operations. So there can be only one terminal operation in the stream, and terminal operations are used to terminate a stream. What is the difference between stream and straight stream is sequential, parallel stream is multi-threaded one. I've explained you, right? So I'll further create videos on all these things. But yeah, this is the basic interview question series for stream API. Then what is the difference between map and flat map. So in the further example videos, I'll give examples of flat map also, but for this video I've just mentioned this because it is an important question. So what is map and what is flat map? Map is, so in this case we have a list of integers, right? 87, 11, 50, these are integers. So directly on this I wanted to operate, so I went for map, right? This map will take each element. What if I had something called a custom one, a list of employees suppose, and this employee class would be having some age, employee ID, whatever, right? And this list would be of like EMP1, EMP2. So based on I could have opened a stream on the employee list, nothing big, but then what if I wanted to operate on something inside that employee object? So this employee object can have age, name, ID, can have address, can have this address can have cities, different cities. Suppose you want to pull up those cities and operate something on that, right? In that case you will go for flat map. What will flat map? It will flatten, it will open, it will flat the whole list thing, and it will help us to operate on that inner thing, list within the list, right? It will help us to operate on that. So that is what flat map is. So I'll give further examples of all this in my further coding videos. But from interview point of view on streams in Java, this is it, and this is very important. For more such videos, please subscribe to your Techie Buddy, and thank you so much.